Hello, everyone. Welcome to our product. This is about dynamic urban road traffic noise simulation modeling using the passive and public available data in the transport. My name is Jenny Ma. I'm an assistant professor in transport at KTH. Also, the co-PI Roman Rupla, associate professor in sound and vibration at KTH. This is our project team. We also have two PhD students. One is from the noise modeling and one is from transport modeling for this product. For the background, basically we know the noise is also cause some health concerns about the annoyance, sleep disturbance. And if you look at the figure, basically 20% of the EU population, they are exposed to harmful noise levels. And also we know the urban population actually keep growing. And this noise problem in the urban environment actually has this major health and economic impacts. And in order to address that, we need to have a detailed assessment of the noise levels and also the representation and innovative mitigation strategies coming after that. So the problem of current noise monitoring is mainly because this current noise map, they are basically based on the average yearly traffic flows. They are static and they are basically based on the long-term average, which is incomplete in the temporal space and also in the space. And also usually it has a low accuracy. And with the bottom-up noise emission evaluation, we would like to expect we can have like more accurate and dynamic full spectrum noise emission modeling. And also based on that, we can also like look at like the detailed like traffic management strategies or like other mitigation strategies so that we can really reduce this noise impact to our society. So this is our project framework. We have like three different work packages which are colored differently. So for the first work package is basically we would like to based on different source of the traffic sense data to try to estimate this multi-class dynamic region destination vehicle flow matrix. So basically like for different vehicle type, like for trucks, buses, or like the cars or bicycles, we would like to have different OD metrics by time to be estimated. And then like we can use some open source traffic simulators like the Sumo, which is a microscopic simulation. So we can have this detailed like individual vehicle information, like the vehicle location, the speed, and the acceleration. So those like important factors actually drive this instantaneous noise emission model calculations. And based on that, like we also need to model this noise propagation in order to get at a certain location what would be the noise level. So after we get this result, basically we will develop some realization tools and for example this web-based interactive GIS software to try to realize this. This is like the technical pipeline for this full spectrum dynamic emission model. So from the data side, basically like we try to leverage on the traffic sense data. Then we would like to estimate this multimodal traffic OD matrix. And then combined with this network, we can do the simulation. Right? From the simulation, we can get the vehicle state, like the distance, speed, etc. And then we can plug into this noise model, we can calculate the emissions, and then we can realize it. But when we do the simulation, it is a common issue is that like our studied area is not the whole area, right? Usually we focus on a small area. But when we do the simulation, we cannot really only simulate this small area. We only need to simulate the whole area and then extract the information. So for this example, like the selected case study area is this sort of moment is here. And then like basically like we would like to do the macroscopic simulation. We want to get the detailed vehicle trajectories. But it seems like there's also like the vehicles coming in and also coming out from this area. So we also need to simulate the whole Stockholm region. And the question is that like if we have a simulation of the whole region and then we have the simulation for this small area, there could be some potential issues that these two simulations will give like inconsistent output for the flows in this boundary. So how to solve that is just basically we propose this hybrid simulation, which is also like common in traffic simulation domains. So we have this mesoscopic simulation. Basically, it can run faster for the large area. And we have this sumo that we use for this macroscopic simulation for the studied area that we would like to have with a detailed simulation of the vehicles. And then to solve these boundary issues, basically we will do the iterations. And if we find the flows in these boundaries inconsistent from these two simulations, we will try to adjust some of those input or the model parameters in some of these models, and then we will iteratively to converge to something that these two simulations actually will output the same or similar quantities for these boundaries. So for the past several months, basically we try to collect the data and also set up the simulation. The data that we basically collect is from the dynamic simulation software. So this is the one, the city traffic simulation model that is used by the Swedish Transport Administration. It is well collaborated for the network and also for the OD demand. So this is the basis that we would like to use to develop like for this product. Some technical like challenges that like for different software, basically they have different model approaches. They have different ways to represent their network, to represent their vehicles, to represent their demand or the population. So we need to do some transformations. Since like I mentioned, like we need to do both use MUTSIM to do this mesoscopic simulation, but also the sumo to do the macroscopic simulation. So from dynamic, we translate like all the information as the to the format that the MUTSIM can accept. And then from the MUTSIM output and also the MUTSIM network, basically we also transform to the sumo input, right, so that we can get this two simulation ready for this product. So now like we have finished this simulation setup, basically we can now run the MUTSIM for the whole Stockholm region. And also we can run the sumo for any selected area in the whole region. It's basically just to show like some of the vehicles running on the road and networks. For the next step, basically we would like to, based on the simulation output, right, which are the individual vehicle trajectories with locations and speeds, and then we will like plug in the noise emission calculation model from the Romance team, and then we can realize or like to estimate the different scales of the dynamic noise emissions. It can be like the noise emission from individual vehicles. It can also be the noise for different road segments, or like it can be for the different areas. But like for the area like noise emission model, basically we also need the propagation model to be plugged in for this purpose. Hopefully we can finish this task, and also in 2023. Basically, it's a prototype based on simulation data, but the simulation is well collaborated in the real world. And for the 2024, So we are going to look at this multi-class dynamic noise emission modeling. So basically, we will also look at for different type of vehicles, we may need different noise emission calculations. Then we will combine them so that we will do this multi-scale realization at the end. Okay, that is our product. And if you're interested, feel free to contact us. Thanks very much.